All right, so for bell work today, we took this data, we typed it into our graphing calculator in our stat menu. So remember how we do that? We go stat, edit, we typed in L1 and L2, we typed in all that data. A real quick check here, we went second catalog, which is the number 0. Remember, you need diagnostic on. If you've turned diagnostic off or you reset your calculator, it's in alphabetical order. So we are going down here to diagnostic on, hit enter, hit boom, we're good. Okay, so again, I typed in my stat, my edit, I typed in those numbers 1 through 7 and 0.5 through 1025. Now the question is, all right, we created a scatter plot. We did number 1. Number 2 says, would this data best be modeled by an exponential, a logarithmic, or a logistic function? Okay, so let's try that out. So we're going to go stat, over to calculate. I'm looking here. The first one it asked us to do was an exponential. Which number are we choosing if we're doing an exponential model? 0, exponential regression. We're going to go to number 0. We're going to hit enter. Let's go down to store regression equation. Let's store this thing. So we're going to go alpha F4. I'm going to store it as Y1. Go down to calculate. Boom. There is my equation. How good of a representation of our data is this? Pretty good. 0.989. That's pretty high. If we hit the graph button, oh yeah, that seems to go through my dots pretty well, especially at the beginning. Great. Let's do it again. Stat, over to calculate. The next one it asks us to do is a logarithmic regression line. Which one of these things am I picking if I want a logarithmic regression line? Number 9, natural log. That's a logarithmic. So we're going to number 9. We're going down to store regression equation. We're going to go alpha F4. We're going to store it as Y2. Calculate that thing. How good of an equation is this one for us? Not so good. 0.44. That's pretty yucky. And think about what a logarithmic graph looks like compared to that. Oh yeah, that's not going to be a good model. Okay, it just doesn't make a whole lot of sense for anything. It's pretty much in the wrong spot. Okay, that one doesn't make any sense. Let's try one more. We're going stat, calculate, and we are going down to logistic. So we're going to go down to letter B here. We're going to store regression equation. Let's store this thing as alpha F4. Let's go to Y3. Down to calculate. When you sometimes, so a couple things about logistic. It's a little bit funky. Sometimes when you do logistic, it will give you an error, and you didn't do anything wrong. Okay, if your data isn't a logistic model, it can't graph it. It won't be able to do it if there's not any logistic model to it. This one, it gave us values. Notice that it didn't give us R squared. When we do logistic, it is not an R squared value. Okay, so it didn't really tell us a lot here. We really need to look at that picture. So let's hit the graph button. There's the first one. There's the second one. There's the third one. Looking at this data right here, which one looks like the best model? 1, 2, or 3? 3. The logistic graph goes right through my data. That's pretty good representation of what's going on. Okay. However, when we pick a model, we want to make sure we know the whole story. So this is, if we were just looking at 0 through 7, I found my answer. Okay, and it's not real close. Let's change our window a little bit. So our window, we only went through 7. Let's say we went through 10. Okay, and let's just change the Y max a little bit. Let's like change it to 4,000. I hate the Y scale. I'm going to make it 1,000. Okay, so I just changed. I made it a little bit more to the right and a lot more up. And the reason I went a lot more up, you'll see here in a second. But let's graph that. That. Talk with your neighbor. If we were to do 8 discs or 9 discs or 10 discs on this graph, which one do you think is your best choice and why? Talk to your neighbor. Come up with an answer. All right. So everybody agrees that it's not the red one still. The red one's garbage still. That didn't change. How many people want to pick the black line, the logistic line, as our best answer? How many people want to pick the blue line? Why? Why the blue line? Annika? Good. So again, she said the black one looks like there's a limit. Logistic model means there's a carrying capacity where at some point you're going to flatten out. Why doesn't that make sense here? Yeah, this is about timing something. If I put infinite amount of disks on these things, would you get done pretty quick? Would you have the same answer for 100 disks as you would have for an infinite amount of disks? No. So there's not anything that's limiting us here. Time is going to just keep the more disks, the more complex it's going to be, the longer and longer it's going to take. Okay, so while the black line made a lot of sense through 7, after 7 it didn't necessarily model our data the same. Yes, sir. Yeah, but then the time, it's telling you a time is happening. So you're saying that, I know what you're saying, that you're saying yes, but I think that's more why it goes up to infinity. Like eventually it's telling you that you can't do it because your answer is going to be like 10 billion seconds, and that doesn't exist in time. So that would make a, yeah, I know what you're saying though. Yes, ma'am. Oh, I thought you did. Okay. So we're coming up with a good answer. That's what today's all about, is understanding the data, what's happening here, but what would it look like if I continued on with this data? So we created our model. It says use your model, predict how long it would take to complete it if there were 8 seconds. So if you did it right, at this point it'd be really easy. Second quit. We chose the first model. So the easiest way to do that would go alpha, F4. I'm going to pick Y1 because I already stored that equation, and I'm just going to plug in the number 8. If I plugged in the number 8, it would take 5,441 seconds, otherwise known as 90 minutes. That's a long time. Okay. If we went on to 9 disks, it would be not a fun time. We go 9 disks. We divide that by 60 seconds in a minute. You divide that by 24. No. I need to divide by 60 again. That's in minutes. Divide by 60 again. It's 5 hours, 8 hours to do that, and we do another one. It's going to keep getting more and more and more. Yucky. Disagree. It gets more complex. It is a weird game. It's one of those things you got to know. Let's try something else. Okay. We're going to do this again. We're not doing a handout today. Everything we're doing is just looking at the screen. So it's not that complex. We're going to do this same concept in terms of modeling some data and then making a choice and being able to back up our choice. That's the lesson of the day. Okay. In the board game Power Grid. Has anyone ever played Power Grid before? It's not I've never seen it before, but some people have seen it before. It is a fairly common game. But Power Grid, basically, you're trying to connect cities with power lines, and the more cities that you connect, the more money you're going to make. Okay, so think of like a game board with the United States, and you're trying to connect cities. Okay, so if you have 1 city, you get 22 bucks, 4 cities, 54, 7 cities, 82, 10 cities, and so on. Okay, which of the following best models the trend of the data in the particular context? Justify your conclusion. So all I want you to do is in your calculator, type that stuff in. Okay, look at that data. And then based off of that data and what we just described, figure out which one of these 4 equations is going to best model this game in the future. Okay, if we were to continue this out, which one's going to be the best one? Okay, and have a justification for what you're doing. That's the most important part. And it doesn't always have to be, hey, the R squared value is better. It has to be, I think it's this because of this reason. And as long as you have a good answer, that's what's going to allow you to be a good model of data. Work with your neighbor, talk to each other, type that stuff in, see how it goes. All right, if you haven't quite gotten super far yet, or it's taking you a second to do it, I want you to be able to use your calculator. If you can use it, great. Here's a graph of it, okay? I gave you the 4 lines here, A, B, C, and D. What I want you to do right now is have a discussion with your neighbor, okay? Based off the data that we typed in, and based off of what we need to do. When we're modeling, here are the 2 questions you got to consider. Number 1, how does it fit the data that's given? And number 2, how well does it fit the trend of the data as I look into the future or the past with the given concepts? Okay, so talk with your neighbor here, A, B, C, or D. Which graph do you think is the best model of our data, and what would the game board use? All right, here we go. 1 if you think it's A, 2 if you think it's B, 3 if you think it's C, 4 if you think it's D. What model are you picking? 1 for A, 2 for B, 3 for C, 4 for D. All right, so I'm seeing 2s and 4s mostly here. 2s and 4s. Let's look at them. Okay. Why would A not be a great representation of our data? Anybody got a reason why you don't like A? It doesn't curve. If you look back at this data, letter A is a linear model. Okay. If you look back at this data, is it growing linearly as we go from city to city? No, it's not doing the same jump each time. And so a linear model here didn't make a lot of sense based on the data given. It could have. They could have changed the game to look that way, but they didn't. So I'm thinking not A. Anybody got a reason for not C? Yeah, at no point in this one does the data go down. They could have. If the board game said, all right, when you start connecting too many cities, now all of a sudden you don't make as much money. That's not a very fun board game. Okay. When you're doing too well, you start losing money. Probably not a good plan. Okay. So we're going between B and D. And again, I'm okay with either answer here. If you pick B and you give me a good justification, great. If you pick D, give me a good justification, great. Those would be the two I'd choose. But somebody have a good answer here. Back up what they chose. Somebody want to talk to it? Sophia, which one did you pick?
So I said B.
Okay.
Because they only have a certain amount of money in
In the board game?
In the game. Like, there's not going to be, like,
maybe they're just doing.
Amount of dollars.
Okay.
I feel like it's got to, like, sort of, like, level.
Okay. I would agree with that, but a logarithmic graph eventually would continue to go towards infinity. The range is infinity.
Yeah.
But I understand what you're saying.
It flattens out more than the other.
Okay, so she is going to describe the idea that it's flattening out. Okay, there seems to be a change in this data as we go up. It is starting to flatten a little bit more, and so she picked D. Great with that. Somebody pick D and give me a reason for it.
I think D because it goes along with.
Yeah, and so great. It's increasing. It's not linear, and it seemed to be a better representation of the initial data. Great. I like both of them. I would agree. D is a better model as we look through those initial dots. That blue line, like it almost goes through exactly. Okay, the purple line, it misses a few. But I agree that maybe, hey, it's starting to flatten out and D doesn't flatten out as much. That's fine. You have to be able to back up your answer with words. Okay, being able to use the math, use the data given, and being able to back it up. That's the concept we want to be able to do here. Questions with that?